Energy is the fuel to power our everyday lives. There are various ways to obtain energy, such as the combustion of fossil fuel, nuclear fission, which is basically the splitting of radioactive atoms, or harnessing solar energy. However, all these methods have its drawbacks. The burning of fossil fuel has high carbon emission. Splitting of an atom produces radioactive nuclear waste, and there are not enough of storage energy during cloudy days. Yet, the main source of our energy is from the sun, as it seems to be providing us infinite supply of energy. Scientists are researching to use the concept of the sun to build it on Earth. But is it possible to build a sun on Earth? Firstly, we need to understand how the sun works. The sun uses the concept of nuclear fusion. In the sun, there is an abundant amount of hydrogen atoms. Since it is incredibly hot in its core, the atoms are stripped apart from its electron from the nuclei, creating a layer of plasma of free-moving nuclei and electron. Nuclei repel each other due to its positive charge. Due to the atom moving very fast, it overcomes the repulsion force, fusing the nucleus, creating a heavier atom. This process releases energy in the form of light and heat, which means it is very hot, hundreds and millions of degrees in temperature. Stars have a colossal size and mass, meaning that the pressure in the core are extremely high. As a result, the atoms surrounding the core are being pulled closer to one another. However, modern technology is still unable to compress the atoms at this large magnitude, but only to increase the temperature high enough to fuse the atoms. To date, scientists have created two methods to heat the atom for fusion reaction to occur. The first method is by using a magnetic confinement reactor, a ring-shaped reactor where they use magnets to control the plasma from being contaminated and cooled by touching the surface of the confinement chamber. The other method is called inertial confinement, where they use lasers to heat the fuel pellet, consisting of hydrogen atoms, in order to heat and compress them for fusion to occur. Unfortunately, these methods are only at experimental stage. And even though we manage to achieve fusion reaction, the amount of energy being used is more than the amount of energy being produced. But if we succeed in this experiment, the amount of energy produced by a glass of seawater will be equivalent to the amount of energy produced by burning a barrel of oil, without having any carbon emission that are extremely toxic. This is because seawater consists of an abundance of hydrogen atoms that are used as the fuel in the fusion reactor. However, specific isotopes of hydrogen are used in fusion, such as deuterium, which contains one proton and one neutron. Also, tritium is used, which has two neutrons instead. There is a large amount of deuterium on Earth that can be obtained easily, but tritium is extremely rare as it is radioactive. Instead, we can use helium-3 as substitute to fuse it with deuterium. But helium-3 are also rare, but there is a large build-up on the moon, so perhaps we can mine it from there. Some may argue that building a fusion reactor can be very dangerous, but it is actually very safe as compared to burning of fossil fuels, which has a very high death rate due to the pollution of air, chemical waste which are harmful to the environment, and nuclear reactors which leads to the disaster of Chernobyl and 3 Mile Island incident. Fusion reactor will not explode like a nuclear reactor, which can melt down catastrophically. If the confinement in the fusion reactor fails, the plasma will only expand until it is cooled but then ceases reaction to fuse completely. Up to this point, we have provided you a method of producing infinite supply of clean energy that are environmental friendly in something as simple as a glass of seawater. So, why isn't this method being utilized? This is because The cost required to build this reactor is estimated to be about $10 billion, and we simply does not know whether it can be succeeded due to its unproven technology. Even if it does work, the risk of investing into this project is too high. An investor would rather fund on projects that are proven to be successful. Nevertheless, if this project were to be succeeded, perhaps it would be worth the risk and have an infinite supply of clean energy.